Now, I know most of you can operate your cameras and get good photos, and many of you already know how exposure works. But in this class, we start at the very beginning. We go pretty fast until we can get to the creative part. So if this is a review for you, just hang in there, bear with me, and we'll cover these very basics up front. The first one is, how does an exposure work? Well, the sun or some other light source is present and it enters your camera. And you can control the light that enters your camera in 3 ways. And there are reasons why you would want to use one way or another, or a combination of the two. The first one is the aperture. Aperture plays an important role in composition and also setting up a shot. Let's take a closer look. Simply put, aperture is the hole in the lens through which light travels into the camera body and onto the camera sensor. To understand, let's look at the human eye. All cameras are designed just like human eyes. The cornea of our eye is similar to the front element of a lens, gathering light and bending it inward towards the iris. The iris can expand or shrink, changing the size of the pupil, which passes light into the inner eye. The pupil is what we refer to as the aperture in photography. The amount of light that falls onto the retina is controlled by the size of the pupil. The larger the pupil, the more light falls onto the retina. The larger of the aperture on the lens, the more light enters the camera. The iris of the lens controls the aperture. It is also called the iris or the diaphragm. In photography, aperture is expressed as f-stops or f-numbers. F-stops are a way of describing how open or closed the aperture is. The smaller the f-stop means the larger the aperture, while a larger f-stop means a smaller aperture. This can be tricky to remember because larger f-stops mean smaller aperture sizes. It's best to think about things as a fraction. So 1/22nd would be a smaller opening than f2, for example. So an f-stop of 1.4 is larger than an f-stop of 2.8, and much larger than f8 or f11. Aside from controlling the amount of light entering the camera, the f-stop or the aperture or the iris or the diaphragm, all of those mean the same thing, has a considerable difference on how the picture is perceived. That is, the depth of field, the area of the picture that appears sharp. A large number, such as f16, is a small aperture size, will bring all foreground and background objects into sharp focus, while a small f number, such as 1.4, will isolate either the foreground or the background and make everything else blurry. Every lens has a limit on how small or large the aperture can get. If you take a look at the specifications of your lens, it should indicate the largest aperture that you can get. The maximum aperture of a lens, that is how small the number is, that's much more important than the higher number, f number, because it shows the speed of the lens. In other words, how wide the aperture will open to let in the maximum amount of light. Lenses with apertures of 1.4 or 2.8 are considered very fast lenses. A lens with a maximum aperture of f4 or f5.6 is not very fast. That's the reason that night photography usually uses very fast lenses like f1.4. It is also worth noting that there are 2 types of lenses. There are prime lenses and there are zoom lenses. Prime lenses have a fixed focal length, meaning they cannot zoom. Zoom lenses allow you to zoom into an object or further away while remaining stationary. In other words, you're not having to move in closer to get more magnification. While prime lenses have a fixed f-stop no matter where you're focused, zoom lenses have a variable largest f-stop. So when you are at, for example, 70 millimeter on a 70 to 200 lens, you'll be getting f3.5 because the lens is not extended very far. But as you increase the focal length, in this case to 200, you'll get less light, and then you'll get a maximum f-stop of about 5.6. In today's class meeting, we're going to concentrate on exploring aperture. We're going to do several photographs of the same subject with different apertures. We're going to be putting our cameras in the A mode, which is aperture priority. So that will allow us to choose an aperture, and the camera will choose the corresponding shutter speed to make the right exposure. And we're going to do several shots of the same subject at different apertures, and then examine our photographs and see what difference the depth of field makes with each of the chosen apertures. Let's get our cameras out.